Lesson 104, I want to do a little bit of review real quick. Okay, if I am finding the circumference of a circle, what is the circumference? The measurement, it's kind of like the perimeter. The measurement from the outside of the circle all the way around to the end, okay? The circumference is if we are measuring the distance around a circle. And what helps me remember is I always see this in my head. Circumference. I see that word around it, which I know that means I'm going around it, okay? Does anybody know the formula for circumference?
Diameter times...
Okay, circumference equals pi times diameter. If you do not know this, you need to know it. Does everybody remember when I took that string? We measured the distance across a CD or a trash can. I can't remember what we used. Does anybody remember?
There was a stool.
Stool, okay. And then we took the diameter, which is the distance across it, and then how many times do we go around with that string? 3 times and a little bit more. So actually what we did was the diameter of that string times 3.14. Does everybody remember that? Okay. Now, what you're going to be learning about today, actually let me teach you one more thing. Okay, so that's circumference, it's on the outside. Area is on the inside. What is the area of a circle? Formula? You may know? You need to know this.
I know what, it's diameter, no, radius.
Yes? Yes?
Squared
times pi. Okay, pi times radius squared. Okay, and this is where we took, remember us taking that and we divided up into 4 squares? Remember that? But we don't use all of the 4 squares. Remember, this part was out of it. This part was out of it. This part was out of it. So what ends up being is we only use up 3.14. It actually ends up being the same thing as pi. So the area of a circle is pi r squared. Everybody remember that? Mm-hmm. All right, what you're going to be learning about today is something called a semicircle. Does anybody know what? The semicircle is half of a circle. So watch this. Boom. That is a semicircle. So, if we were finding the circumference of a semicircle, would we still do pi times diameter?
No, it'd be radius times pi.
Kind of, almost. Keep thinking. It would be half of the answer for a whole circle. So we'd still find the circumference of a whole circle, and then we would divide it by 2, which halves it. Does everybody understand that? Understand that? Okay, same thing here. If I was finding the area of a circle, I would find the area of a whole circle, pi r squared, but then I would divide it by 2, which gives me half. So does everybody understand that this is the formula for a semicircle, and this is the formula for the circumference of a semicircle? Okay? It makes sense to your brain, so don't think you have to like memorize a whole nother formula. Just know what you're doing. You're taking the circumference, and because you're only using half, you divide it by 2. You're taking the area, and because you're only using half, you divide it by 2. Okay? Now, okay. Everybody draw a semicircle like this, a C, with a line down it. Okay, because we're only doing half of the circle. Okay, but then it has this little extra piece. Okay, and I want you to stay with me. Okay, they got that dotted line. Okay, then from here to here is 5. Okay, so draw that on your paper and we're going to talk about it. Okay, on this figure, here's what they're wanting us to find. They're wanting us to find the perimeter. Now stay with me. The perimeter means that I want to know this, which they have is 4. I want to know this. I want to know this. And I want to know the outside of this. Does everybody understand the steps that we're going to take? So we need to find this measurement, which we have. We need to find this measurement, and then this measurement. Does everybody see what we're doing? Because we're wanting the perimeter. And perimeter is the outside measurements. Okay? Now. Okay, I shouldn't have put those circles around it. Okay, so here's what I want you to see. Is we need to know from here to here is what? 4 centimeters, meters. Okay? This is 4 meters. So what is this down here? 4 meters. Okay. Can we discover what this is? Anybody see anything from this that helps us determine what this is? I see something.
5.
Close. Does everybody see this dot right here? I was supposed to kind of put it in the middle. I kind of messed up. Okay? So stay with me. The radius can go anywhere, right?
Yeah.
So can it go here?
Yeah.
So from this dot down is 5. From this dot up is 5. Does everybody understand that?
Yes.
So what is the whole?
10.
10. Excellent. Excellent. I'm just erasing some stuff. Okay. Now, so we've got this little rectangle piece. You see this little rectangle? We know that this is 4, this is 10, and this is 4. Now we have to find this from here, whoops, to here. What is that called?
I don't know.
I'm finding the
Circumference?
circumference. But am I finding the whole circumference? I'm only finding half of it. So let's go in and find out what the circumference would be, pi times d, and then we'll half it, right? Okay, so to find the circumference, I have to do pi times, what is my diameter?
10.
It's 5 radius, 10 diameter. So we know that we can move this decimal 1 place to the right. So it's good. Excuse me, my circumference is going to be 31.4 for a whole circle. But this is just a semicircle, so it's only half. So we're going to half and divide it by 2, and it's going to end up being 15.7. After I divide. Okay? So, that's not the answer, and a lot of people will stop there. That's only the answer to here to here. So this is 15.7. Does everybody see what we've done? A lot of people are going to go, oh, found the answer and be done and forget that they have to find the perimeter of all of it. So now I take 4 plus 10 plus 4 plus 15.7. And tell me what I get.
33.7.
What is it?
I think it's 33.7.
33.7. You're exactly right. Good job. 33.7 is the total perimeter of that figure. Everybody understand? Okay. Now, what do you think we're going to do next? Area. Okay? So we just now did the circumference things. Now let's do the area. Now they're going to draw the same figure. Okay, so I'm going to draw it again. Okay? Not really pretty, but it works. Okay? Now, they go on and put a 4 here, and then they have 5 here again. Okay? So go on and draw the same figure that we did a while ago. Okay? And this time they're wanting us to find the area. Okay. When you're finding an area of, this is called a complex figure, you need to determine what you're finding the area of. Well, we have a rectangle So we're going to find the area of this rectangle. So I'm going to put an A with an R with it. So that shows me that I've got to find the area of a rectangle. And then I also got to find the area of a semicircle. That's why I put an S. So I'm going to put area of a semicircle. So that already in my brain, I know that I'm going to have to find these two areas and then add them together to get the fullness of it. Is everybody with me? Now we've already done a lot of the work. We found this line to be what?
10.
10. Okay, so can I find the area of this rectangle?
Yes.
Okay, what would I do? 10 times 4, length times width. You need to know the area of a rectangle is length times width. So we would do 10 times 4, and we would get 40. And I guess this is in meters, so it's going to be 40 meters squared. Okay? Now we just have to find the area of the semicircle. Well, what's the area of a circle? Formula. Pi r squared, but that's for a full circle. But we're only doing half of a circle, so I'm going to divide it by 2.
1.12.
Okay? So what I would do is I'm going to take this pi and go 3.14 times. My radius is 5, so 5 squared. And 5 squared becomes 25 over 2. Okay? And 3.14 times 25 divided by 2 is going to end up giving us 39.25. Is that what that says? Yep. Meters squared. Okay? So the answer of my semicircle is 39.25. A lot of people want to go on and put the amount.
Wait, don't you have to divide it by 2 though?
Yes, I did already. I did all of it. I did it all in one step. Okay? So I did 25 times 3, which would have given us like 75 point something, and then divided that by 2, which gave us 39.25. So the area of this semicircle is 39.25. The area of this rectangle is 40. So now I'm going to add 40 plus this, and our final answer is 79.25 meters squared. So everybody got it? How you do it? Yes.
But if we're dividing 40 by 2, wouldn't it just be 20? Instead of 25?
No, because this is the full rectangle.
Yeah. So, but then you would divide that. What?
This area.
How did you get 25?
You talking about this one?
Yeah.
Oh, that's pi r squared. R is 5.
Oh.
So squared r times r is 5 times 5. Okay. Does everybody understand what we did? Mm-hmm. Okay. Now, sometimes they're going to give you something that looks like this.
It's always cold in here.
Okay. And they're going to give you this information. That says that from here to here is 300 degrees. So what is from here to here? 60. Does everybody see that? This would be 60 degrees. Does everybody see that? Okay. Now the other information they give us is that from this center point out is 6 centimeters. Okay. Now, if this whole circle is 360 degrees, and I'm finding, they're wanting me to find the area of this section of the circle. Stay with me, okay? So if I asked you to find this much of the circle, and we were to work with the area, then we would go pi r squared divided by 2, because we were trying to find half, okay? But it wasn't half. How much are they wanting us to find? Only 60% of the 360, or 60 degrees of the 360. How much of this circle is 60 degrees?
1/5.
Close. Good try. 1/6. Okay, so I actually could have 6 of these 60s, right? 1, 2, 3, 4, 5, 6, right? They're wanting us to know what is this piece of area. So what fills up this much, okay? Well, what we know about area of a circle is that it's pi r squared. But we're not finding half of it, we're finding a 1/6 of it. Does everybody understand how we got that? 60 degrees is 1/6 of 360. So guess what? We're going to divide by 6. Does everybody understand? Then you just insert your numbers like normal. 3.14 times my radius was 6 centimeters, so 6 times 6 is 36. Okay? And then I'm going to divide the full answer, 3.14 times 36, which is, it doesn't tell me. And then I'm going to divide this, I was going to do it, 36 times 3.14.
To find the diameter, wouldn't you do 6 plus 6? Oh, wait. No,
Radius.
Finding radius. Okay, yeah.
Radius times radius. Thank you, though. Listen, I make mistakes, so please. If I ever mess up, I want someone to tell me. Okay, so if I do 36 times 3.14, okay, so I end up getting 11304, and then when I divide that 11304 divided by 6, I end up getting 18.84, and it's in centimeters squared because we're working with area. Okay, does everybody feel like they got it? Okay, so this portion of our circle is 18.84 centimeters squared. Okay? Everybody understands how to do it? It makes sense, but it's kind of hard because everything's new. Okay? Now, let me share one more thing. Sometimes I just think they give too much right now. Okay? Okay, if they told me in this figure, well, I don't know why they forgot B, but B's not here. Okay, so they tell me in this figure, central angle AOC is measured 70 degrees. Then they tell me what is the measure of ADC. So they're asking ADC. That right there. Well, we know a whole circle to be 360, right? Okay, so if this is 70 degrees, what is this part? 290, right?
I was working on it.
290 degrees. So everybody got that? Okay, now, all I need to share with you is that there are minor arcs and major arcs. Minor arc, major arc. And let me give you an example of a minor arc. A minor arc is if I went, this is the arc AC. Everybody see that? This is major arc ADC. So anything past a semicircle on an arc, if it's bigger than a semicircle arc, then it is considered a major, which makes sense in your head. Major is bigger, minor is smaller. So a smaller arc is called a minor arc, and a bigger arc is called a major arc. Okay, they just want to teach that right now, whatever. Okay, so now, here's what they tell me. That was just to teach you the minor and major. So listen to this. I've got an axis. 1, 2, -1, -2. 1, 2, -1, -2. Okay? Y-axis, X-axis. Okay, here's what they tell me. A minor arc with the radius of 2 centered at the origin is drawn from the X-axis. They're saying that it's going to be a radius of 2, so we know that the line goes from center point to 2. okay? But here's what it says. From the positive x-axis, so we know that it's this one, we're going from the center point to 2 on the x-axis, and to the center point to 2 on the y-axis. So here's what it says. It is drawn from the positive x-axis, we know this is positive x, to the positive y-axis. So we're going from here to here. Okay, so I want you to listen to the problem again so that you understand this. A minor arc with the radius of 2. Radius means from the center point out. So it could have gone here, 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 or here. Everybody gets that? Then it says it is drawn from the positive x-axis, so we know that it's a positive and a positive y-axis. Okay, so we know it's this one, and the arc goes from here to here. What is the length of the arc? They're wanting to know what is the distance from here to here. What are we actually doing? We learned this just now. We're finding the circumference, sort of, okay? Because the outside of a circle, if we went all the way around, this would be the circumference, right? But we're not finding the circumference of a full circle. We're only finding the circumference from this spot to this spot. Fourth. So you would find the circumference, pi times d, of this whole circle, and then, because we only want a fourth of it, we would divide it by 4. You're going to be totally lost because you haven't heard the rest of it, okay? You may not be totally lost, but does everybody understand? Okay, so then we would divide that one by 4, which I'm not going to work it out, okay? And time is up.
We really do not have any time.
We do not. We don't. So I apologize. I wanted to be